Good afternoon, everybody. Welcome back to lecture number 34. We're in week 12 الحين. Okay. Last time we talked about, we continued talking about the last time we talked about
Example 10.
We talked about example 10. We will revisit it real quick. And if you have any, do you have any questions about example 10? So example 10 was talking about 3 different operating points. So in the test, if I want to ask you example 10, probably I will say a car at point 2, 1, and 3. So example number 10. Okay, I did recheck Dr. Abu Bakr Salim's video, and this was the direction of the quantity. Okay? So for example, the low torque, the direction is positive. If it's left, the direction is the opposite direction. Okay? The field was kept constant at all the other parameters. So example number 10, what did we have? We have 440 shunt with armature current 76, speed 1000 RPM, we have RA, we have RF, and we have the rotational losses to be 1 kilowatt. The load of the motor is bidirectional, such as EVs. EVs are what? Bidirectional. And the first question, طبعا اللي حصل في السؤال هذا كان يعني basically we want to study the impact of moving between different points and see how the speed will change based on the braking, okay? So no load speed of the motor. Usually no load speed is found through the formula EA equal K flux. So you have to find the K flux originally, which is 3.93, which is found by 2 pi n over 60. So you need to find the constant first. How did we find the constant? Using, I think, rated speed 1000 RPM. You do the math, you get 3.93. So to get the no-load speed, you need to, instead of applying EA would equal to VT. Always at no load, EA would equal to VT. Why? Because IA is 0. Okay? Now you do the math, you get 169 RPM. Always verify. This is the no-load speed, 169 RPM. This is the rated speed, 1000. Usually the no-load speed is higher. Okay? Does it match the curve? Yes, no-load speed is higher. Then part 2, motor speed, where the armature current 60 amps during regenerative braking. So regenerative braking, what quadrant is that?
2 and 4.
Quadrant 2. And remember, what was the x-axis? Torque or current. So if it's in the second quadrant, that 60 will be minus 60. Okay? It's regenerative braking. Because it's minus 60, you do the math. It will be now, you can use this equation. Make sure to include this equation. It's Vt minus RAI3 over the flux, K phi. So the speed will be 117 radians per second, and it is higher than the no-load speed. It's higher than the no-load speed. Why it's higher? Because we are in the regenerative braking. Your EV is going down the hill. It's generating electricity. Do you want to hear the story that happened to me the day before yesterday? So the day before yesterday, I had a very interesting case. I have a hybrid car, okay? My car is hybrid, not EV, but it's hybrid. So during very low speeds, it's purely electric. What happened is I didn't do it. I forgot to put in the, so we have what? DNP, صح? So I was in a position where I put it in the P, but without the brake. For some reason, the brake was activated and then deactivated. Okay? No, I put it in the D, I put it in the D, and then I forgot, I turned off the engine without putting it in the P. But it was in a position where it was going up the hill. So it was motoring or regenerative braking? Motoring. So who was, for some reason, if it was a little bit flat, the car would go forward. If it was, and I challenge you, nobody knows about this, but EVs will, hybrid EV, if you put it, if you're on a flat road وتحطها على D, it will keep cruising. السيارة العادية تحطها على D, it will stop. EV, it will go cruising. And try this experiment. Anybody knows a family who has hybrid car? Try this test, okay? We can try it outside if you want. EV or hybrid EV, في D, don't leave it on the D. It will keep cruising. ما في شيء راح يوقفها.
دكتور دو يمين ان
لا الان ما تسوي شيء.
دي طيب طبيعي
بس يمشي أصلاً.
لا ما تمشي سرعة. بتوقف.
اذا انه فلاش رود
بتوقف. ما موقفة.
ما توقف
بس
فلاش
يلا
رود
طافية
فصلت البريك
لا السيارة شغالة. At some point it will stop.
لا لا بتمشي.
Whatever. This is not the story. The story حصلت متى؟ كنت a little bit tilted، كانت القوة اللي تدفها مخليتها ثابتة. Get it? When I turned off the engine without the P, for some reason the car went back. During this time for an EV, it was held by the motoring mode. If you remove the power, because the flat is a little bit tilted, it cannot go. If it was a flat surface, if you turn off the engine, it will stop. خلاص. It will not cruise. السيارات العادية تمشي ما راح توقف مستحيل.
اذا ما في
إذا فيها وزن.
حتى بعد فريكشن.
اي ما راح توقف اذا عدي ما راح
مش
توقف
ممكن يجير مش ممكن يجير والمحرك يدور
إذا صح
حتى
يكون في
بريك شوي عامل برضه بتمشي شوي
متأكد؟ Anyway, في الدي حق الEV, if you turn off the engine, it will go down. That's the story. Okay? When it happened to me, I was scared. Immediately, يعني شغلت السيارة حطيتها على البي. This EV is difficult to do. I think number of people, when I put it in the R, حطيت السيارة على الR, في الهايبريد, there is no sound in an engine. So they put a sound, humming sound. I think number of people in the street who told me there is something wrong with my car, more than 30 people in the past 5 years. Every few months I get one guy telling me something is wrong with your car. So this is a safety feature. This is a safety feature.
Because of the humming sound.
The humming sound. If you put the R, there's humming sound. Then for safety, actually, you don't hit the passengers. Anyway, thanks for telling me D إنها على طول تقدر تمشي. It's been a long time.
بونس
لا it's a fact. So that's the thing. The developed torque point. خلصت المحاضرة. The developed torque at point 3, which is the regenerative braking. How to calculate the torque? You calculate the torque using IA3. It's already given. I told you last time, if you put minus, is it correct?
Yes.
Yes, if you put minus, it's correct. To be consistent. يعني هنا حطينا في current minus. Why not we put it here? Okay? Question number 4. Find the EA during regenerative braking. You can calculate the EA using the regenerative braking using our famous equation, K flux omega 3. And omega is positive or negative for regenerative braking? Positive. And it is higher than LVT. It's higher than LVT. Then I ask you to find the power delivered by the source under normal motor operation. So now we go back to 1000 RPM. We go back to 1000 RPM. Or you go back to 76. 76 plus the field, 80 amp by the source. We have 76 plus IF. It is 80 amps, so what's the total power? 35.2. Then the question went to generated power during regenerative braking. You use the IA comes minus 60. So note here, he subtracted the IF from the IA. They have a different sign. Another student might say I3 equal minus 60 plus 440 over 10. The field current is always positive. So what's the final answer? Minus 56. Okay? This is the current of the motor. The power is easy. 462 times 60, it is 27. If you put a minus indicating it goes back to the supply, that is also correct. So if you put a minus here, minus here, minus here, it will be correct. Okay? The part H, total losses under regenerative braking. What are the losses for DC? Is always,
Rotation.
no, it's always R square R. So you get VT square over RF, RAI3 square plus the rotational losses. Keep in mind, if I ask you in the test, what are the electrical losses, you only include this. What are total losses? You include the rotational losses, which are mechanical. And the power, the last question about 10 was asking about power delivered to the source under regenerative braking. It is this 27, or we call it minus 27. You get rid of the losses. But however, Dr. Abu Bakr Salim, who taught the lecture last time, he indicated something very interesting. He said this is a wrong answer. It should be minus only the electrical losses. Do not include the mechanical losses here. So he leans more toward minus 3.12, which is 24.64 kilowatts, because this is developed before the rotational losses. So this is a correction. However, Dr. Al-Sharqawi, who wrote this book, yes, his name is Dr. Sharqawi, not Sharqawi حق الماء, another Sharqawi. You know Dr. Sharqawi?
Yes.
Who knows Dr. Sharqawi? He taught me math 001. Yeah. Very dangerous professor. So why did he ask you to solve all the odd numbers, and if you have time, go over the even numbers?
Because he brings from the odd.
Hmm?
He brings from the odd.
He wanted you to train your brain. That's it. By exposing yourself to very tough math problems. He wanted to fix you from high school math to college level.
So, Doctor, can we see the question again for the last part?
Okay, last question is and find the total delivered power to the source under regenerative braking.
But it makes sense.
Rotational losses ما لها دخل. It's
Yes,
gonna happen.
But you lost it. What is
No,
the
الباور
to the generator?
الباور
At the end.
الجنريتر مو يعني ولدها الهايبريد فييكل انجن ولدها للباتري. هذه you don't care about rotational losses. يعني it's electrical interchange.
Ignore.
الكفرات minus rotational losses. It's all electrical system. Why you put rotational losses into the electrical system? فهمت؟
Yes.
فالدكتور أبو بكر سالم is correct. Dr. Sharqawi, I think he's wrong. That's why يعني both are accepted in the test if you put minus 3.12 or that. But I think the correct solution is this. This is not obvious. And شوي is tricky. Okay? Did you get the logic? Why rotational losses may not be counted when we do regenerative braking? Because the power exchange is purely electric. Yes, at the shaft, we have to subtract rotational loss. Yes.
من وين جبت 3.12؟
It's electrical minus 1,000. ما في 1,000 rotational.
It's 4.
Yeah. If you add 1,000, it's 4. Okay, we have TVR. What's TVR? So one way to do braking. So now we discussed the test up until the braking, but how to do it, which is not covered in exam 2. We have similar methods. We have counter current braking. Do you remember the counter current in induction? Yes, you remember it? So we basically counter current the field of induction machines. Here, the counter current is not. By reversing a DC supply on the motor terminals, the current will be reversed and the motor torque speed characteristics is changed from first to third quadrant, which is both torque speed will be negative. The supply voltage can be reversed using, for example, a chopper. We move from quadrant 1 to quadrant 3. But can you move without going through quadrant 2? You always have to go through quadrant 2 in order to go to quadrant 3. And to go back to quadrant 1, you have to go through quadrant 4. That's why regenerative braking is always present if there is any braking event, including the counter current braking. So the easiest way to brake is just you reverse the torque and speed. Let's see how this works. You start point 1, torque speed characteristic, we are at point 1. Assume that a load is constant. For now you reverse the direction, reverse the supply. What will happen? You have to jump to point number 2. You maintain the speed. However, the current becomes extremely negative, very big negative. Can you change the speed directly to 3 or 4? No, because you have to go through the process. When the supply is reversed, using what? Osama, how do we reverse the supply? Using the power electronics. We basically change the MOSFETs that are on. Okay? If it was 1 and 3, it becomes 4 and 2. Anybody has napkins, please give it to me. I appreciate it. Okay?
شو دكتور؟
Napkins عشان دكتور اللي بعد شوي. When the supply is reversed, the machine operating point starts from point 2, regenerative braking. Immediately it jumps from here to here. But what's the issue here? The current is huge, so IB is big. Can you see why it's big? يعني لو عكسنا الموسفتات, there's going to be a huge negative current. But the speed will be the same because the speed needs time. The motor is disconnected from the supply at point number 3. What will happen is we will go all the way until we reach a speed that is 0. If the speed is 0, what does that mean? It means it's effectively short-circuited. So these are the 3 equations for points 1, 2, and 3. What do you notice about point number 2? We have I2 is minus V2 minus EA1 over RA. That's almost twice the rated voltage over RA. We will continue next lecture about TVR. Do you want to have the lecture on Wednesday, the additional lecture?
تفضل الأسبوع الجاي دكتور.
Okay, we'll make it next time. Yes, please.